Now that we've used the last few videos to prepare our data model of Stephen Curry's shooting history for the Golden State Warriors, we can begin plotting this data in Power BI Desktop. As always, you're welcome to follow along with me or attempt this later. This is going to be a more complicated report, so we'll break it down into multiple videos, and throughout, we'll introduce you to more features of Power BI. Let's get started. We're back in Power Query, where we ended the previous video. Before we load the data model, let's cover one last topic with data modeling, specifically index columns. In Power Query, an index column is a simple column you can add to your query that generates a different number for each row in the data set. It acts as a unique identifier for each record in your table. In database design, we refer to these unique identifiers as primary keys. Sometimes they appear as long randomized text strings, and other times they can just be whole numbers, starting at 0 or 1 and incrementing up into the millions and beyond. Other times, primary keys can be composite keys that are created by combining two or more fields together, similar to how we merged columns in this data set to create our date column. Primary keys are a vital part of database design and data modeling. Besides uniquely identifying each row in the table, primary keys can also be used to create relationships with other tables, and we'll cover that topic a bit more in a later video. Some datasets we work with may come with unique identifiers for each row already, in which case we maybe wouldn't need to add an index column. For what we're doing here today, our main purpose in adding an index column to our shot data is so we have a unique identifier attached to each row, to each shot Steph Curry took. This is going to be important when we start creating our measures in Power BI Desktop. So, to add an index column, let's go to our Add Column tab on the ribbon, then find the Index Column button. There's a drop-down menu here that will let us choose from different options on how to create our index column, such as starting the number from 0 or starting from 1, which is largely a matter of preference for the person creating the data model. I would like to start from 1, so that's what we're going to select, and Power Query is immediately going to create our new index at the far right end of our table. I'd rather it be at the start of the table, so we're going to right-click on Index and tell it to move to the beginning of the table. Now, it's our first column in the table. Lastly, let's give it a friendlier name than Index. Let's double-click on the column header and rename it as Shot ID. Now that we added our index, let's hit Close and Apply to save our data model and bring everything into Power BI Desktop. Once the data model is loaded, let's start by adding a few items to our page. First, since we're dealing with over 12,000 shots across 9 years of data, let's do a little filtering. We're going to add a slicer to the top left of our report, and then we're going to drag and drop our season column onto that slicer. When we first drop season onto our slicer, it will give us a list of seasons to choose from, but I'd rather see this as a drop-down menu, so I'm going to use the slicer header to change this into a drop-down, and then resize the slicer so it doesn't take up as much space on the page. Next, I'm going to add a simple table to my report page, and I'm going to add date and opponent to start with. Notice how the date column looks. The date has been broken down into its individual components, similar to what we did in Power Query. We can see the year, quarter, month, and day of each date. This is the date hierarchy, and Power BI defaults to showing dates this way because it makes it very easy to aggregate values at different periods. For example, if we were analyzing sales data, using a date hierarchy would be a really easy way to get a total of our company's sales for the month, quarter, and year. A very useful feature, but not really what we want to use for this exercise. To change the way the date is represented in this table, all we need to do is select our table, go to the Visualizations pane, find our date hierarchy, and click on the down arrow icon to bring up the options. You can see at the bottom of the menu are date and date hierarchy, and date hierarchy is selected. I'm just going to switch this to date, and now my dates are no longer broken out into a hierarchy. Now the next issue is our dates are in a format I don't like. These dates are way too long, and I really don't care what day of the week the game was played on, although maybe it would be interesting to analyze if Curry shoots better on Saturdays instead of Sundays. But let's stick to the plan. When we changed how the numbers in the country's data set were formatted in our Week 1 lessons, we just clicked on a column from the report editor and used the Column Tools tab to change them. But I'm now going to show you another way to do this using the data view. I'm going to navigate to my data view, find my date column, and then go to the Column Tools tab and change the format to a much shorter line, like M/D/YYYYY. That will save space in the report, and it still gives me the information I need. While we're in the data view, we're also going to reconfigure two more fields. The left.px location and top.px location fields give us the coordinates on the basketball court where Curry took each shot, and they're going to give us the opportunity to create some really cool visualizations soon. But before we can do that, we need to change how they're formatted. Let's click on the first one and go to the Column Tools, find the Properties section, and change the summarization setting to Don't Summarize. Then, repeat this process for the second column. Changing this setting is going to tell Power BI Desktop to not automatically aggregate these fields anytime we add them to a new visual, because these fields are not designed to be aggregated. They're just coordinates, and summing or averaging them would not make any sense and would definitely mess up our visualizations. Now I think we're ready to define some measures. Let's stay on the Data tab for this, go to our Home tab, and click New Measure. The first measure we want to create is our most basic measure, total field goals attempted. This will be our most important measure because it's the root of so many other measures. We're going to reuse it several times. And this is where our index column comes back into play, because my formula is going to say simply total field goals attempted equals distinct count of Curry shots shot ID. In this DAX formula, our shot ID, the index we created earlier, uniquely identifies each row in our data set, and each row is an attempted shot by Curry. So all we need to do is write a distinct count function, which looks at the shot ID column and counts each occurrence of a number in that column. We should get hundreds per season, adding up to over 12,000 overall for the entire data set. But that's just the beginning. Let's use our new total field goals attempted measure to create some more. In our next one, we want to return all of the field goals that Curry made, which will later allow us to calculate his shooting percentage. To do this, we're going to use a little function called calculate, which takes a measure and filters it by a set of criteria. In this example, we're going to take our total field goals attempted measure and filter it by shots that Curry made, where outcome equals 1. It should be obvious, but FG in this formula stands for field goals. Calculate is one of the most important functions in DAX because of its ability to alter how measures are calculated. It is one of the reasons why Power BI professionals emphasize the benefit of explicit measures being reusable. For me to get the vast majority of measures I need for this exercise, all I need to do is define my total field goals attempted measure once, and then I just create other measures that reference that first measure and filter it in whatever way I need. Let's do a few more. So for total field goal percentage, I'm just going to divide the total field goals made by the total field goals attempted. And then, in the last argument, I'm going to put comma 0 to just use this alternate result for whenever we have to divide by 0. Total FG attempted shot value. For 3-point field goals attempted, I just need to use the calculate measure and tell it to calculate the total field goals attempted measure, but to filter on rows where the shot value is equal to 3. Finally, for 3-point field goals made, we can calculate it 2 different ways. The first way, I can calculate the total field goals made measure and just filter it by ones where the shot value equals 3. Or I can calculate it by taking the 3-point field goals attempted and say where outcome equals 1. And for our final measure, for 3-point field goal percentage, we just need to divide the 3-point field goals made measure by the 3-point field goals attempted measure. And again, we're going to use the comma 0 to tell DAX what to do if it ever encounters a situation where it divides by 0. Now let's go back to the report editor and add all of these measures we just created to our table, starting with total field goals attempted and ending with 3-point field goal percentage, and look at the results. At this point, we've defined 6 explicit measures using a distinct count of our index column as a sort of base measure or root measure from which all other measures are derived. You can see how I reused these measures over and over again to keep my formulas simple and clean, and you can see how we used calculate to change the context of each measure using specific filter criteria. This yields a table full of shooting stats for Steph Curry's 2018 season with the Warriors. Now, let's do a little formatting and organization of our measures by heading to the Model tab. In week 1, I mentioned how we can use the model view to see all the tables in our model and how they relate to each other. In this case, we once again only have one table, so that part isn't very interesting at the moment. But what might be more interesting is how we can use this tab to efficiently format and update our measures using the Fields pane on the far right. To illustrate the possibilities here, we're going to control-click to select all 6 measures we created. And you can see there's a properties pane here which gives us details about the group of measures. We can create a description for each and change how they're formatted. To illustrate the possibilities here, we're going to control-click to select all 6 measures we created. And you can see there's a properties pane here which gives us details about this group of measures. We can create a description for each and change how they're formatted. But for now, all we're going to do is fill in this little box called Display Folder with the word Metrics and hit Enter. This is going to group all of our measures together into a little folder within our data set, making them easy to find. Then we're going to control-click all the fields from our original data set, all the things that are not measures, and put them into a display folder named Fields. This will in turn keep them all together nice and organized. And now let's go back to our report editor. Notice how our Fields pane is now much cleaner now, and everything is grouped together. Using display folders is a great way to organize your data models, especially as they get larger and more complex. Now that we've defined our most important measures, this is a good place to take a break. We've added an index column to our data model, reformatted a few fields, introduced you to date hierarchies and how to handle those, and defined the explicit measures that are going to be the focal point of our report analyzing Steph Curry's shooting data. In the next video, we're going to build our first visual of the shooting data, and we're going to break down those shots by their distances from the basket. See you in the next lesson.